In this video, we will work on more than 70 ideas in algebra in AMC 1012, and also in our next videos, we will work on number theory, geometry, combinatorics. And as I said before, there are around 40-50 important background ideas that are repeated in around all years of AMC in combinatorics, algebra, number theory, geometry. If you want to learn them or want to solve more problems, want to prepare for any math exam, feel free to send message to my WhatsApp number in the description. Okay, we will work on many ideas. For example, let me show you. We will work on Vieta's formula, polynomials, important idea, and also trigonometry. Lots of formulas in trigonometry that are so much important. You should learn all these things. Identities, the important identities that you have to memorize for exam. And for example, geometric series, some techniques, telescoping rule here. Again, another trigonometric formula when you see nth root, what are the approach? And logarithm, important formulas in logarithm, and also quadratic formula, quadratic equation, all things about quadratic. When you see floor, the important technique that is also useful in AMAT is what? Long division, partial fractions, and also when you divide two polynomials and you want to find the remainder, the idea is what? Okay. This problem is problem in AMC 10 A 2022 and also AMC 12 A 2022, problem 16. And we want to use same idea also in this problem, AMC 10 A 12 2017 and AMC 12 A 2017. Okay. Let's start with this problem. Try to solve this problem first on your own. Okay, it says we have, for example, roots. Okay, the roots are R1, R2, R3. It says are the height, length, and width of a rectangular box. And a new rectangular box is formed by lengthening each edge of the original box by 2 units. So if the roots are R1, R2, R3, then the volume of the new box, because it says by lengthening each edge of the original box by 2 units, so it will be R1 plus 2, R2 plus 2, R3 plus 2. Okay. Now let me tell you idea 1 here. Vieta's formula that is useful in many years of AMC is what? Suppose we have an xn plus an minus 1 xn minus 1 to a1x. Let's write also an minus 2, for example. Xn minus 2 to a1x plus a0. We know that each polynomial with degree n has exactly n roots in complex numbers. Okay, so this is, we can call it idea 2. When the degree of a polynomial is, for example, suppose it is p of x. When the degree of p is n, then p of x has exactly n roots. in complex numbers. And P of X has at most n roots in real numbers. Okay. Now it means what? Maybe some of them equal. Means what? You can write it as an. For example, suppose roots are r1 to rn. X minus r1, x minus r2 to x minus rn. Now, if we consider coefficient of x to the n, this side is an. On this side, again, it is an. So it's okay. If we consider coefficient of xn minus 1, this side, an minus 1, this side. When you want to select a coefficient of xn minus 1, you should select, for example, from all of them, x except one of them that you select, for example, minus rn. And so it will be an minus r1 minus r2 to minus rn. So we can conclude r1 plus r2 to rn equals negative an minus 1 over an. Then if we consider coefficient of xn minus 2, left side here, will be an minus 2 on right hand side. You should select 2r, for example, minus r1 minus r2, then from rest you should select x. So it will be an times r1 r2, because minus r1 minus r2 will be r1 r2 plus 2 rn minus 1 rn. Now we can conclude r1 r2 plus 2 rn minus 1 rn equals an minus 2 over an. And so on. You can keep writing coefficient of x to the 0 or constant term is a0 here. And on the right hand side, it will be an times negative r1, negative r2 to rn. So it's negative 1 to the n, r1, r2 to rn. So we can conclude r1, r2 to rn equals a0 over an, negative 1 to the n. Now, why this part? This Vieta's formula is useful. Sometimes we don't need to find roots or what, but we need some of the roots, product of the roots, something like that. Then we can use Vieta's formula, like this problem. Now that you know Vieta's formula, try to apply Vieta's formula and calculate r1 plus r2, r1 plus 2 times r2 plus 2 times r3 plus 2. Try first on your own. Okay, here, if you want to calculate this part, we say it is equal to r1, r2, r3 plus 2 times r1, r2 plus r1, r3 plus r2, r3 plus 4 times r1 plus r2 plus r3 plus 8. So now we use Vieta's formula on this polynomial because r1, r2, r3 are roots of this polynomial. So R1, R2, R3, you can, if you forgot Vieta's formula, let me tell you a trick to remember that. It's minus 39x squared plus 29x minus 6. So you say it is equal to 10x minus R1, x minus R2, x minus R3. So you can say, okay, minus R1 minus R2 minus R3, which is negative of R1, R2, R3, times 10 equals what? Equals 6. So you can cancel negative, it will be 6 over 10 or 3 over 5. Plus 2 times R1, R2, so you say R1, R2 is plus the coefficient of x, because for example negative R1, negative R2 times x is related to 29, so 29 over 10. And I told you we had this formula completely here. You can memorize. Okay, it's better to memorize, but if you forgot this, you can use this trick to find the R what. So, next one is 4 times this part. R1 plus R2 plus R3, coefficient of x squared, 39, negative 39 over 10. And plus 8. Now we can cancel these 2, 5, here 5, 2. So if we use common denominator 5, it will be 3 plus 29 plus 2 times 39 is what? 78 plus 5 times 8, 40. Okay, so now if we add these numbers, 33 plus 29, 32. 32, 110, 150, and it will be 150 over 5, which is 30. Okay, so the answer is choice D. So we solve this problem completely. You can do this one as homework number 1. Okay. Now because we worked on these polynomials, let me tell you 2 more ideas related to polynomials. And we have n roots, idea 3. If degree of p of x equals n, degree means what? Maximum power. For example, here the degree is 3. If degree of p of x is n, and for example, p of x1 is 0 to p of xn plus 1, we have, for example, n plus 1 values that are 0 and xi's are distinct. So it means what? If we find n plus 1 values, but the degree of p of x is n, but we find n plus 1 values, that p is 0. But we said we have n roots. Here we found n plus 1 distinct roots. Then we conclude p of x is 0, means all coefficients are 0 for all x. Okay, this sign means for all x. Another thing about polynomials, for example, if you consider, let me tell you, for example, it means what? Suppose we have ax cubed, for example, plus bx squared plus cx plus d. It is equal to 0 for example, x1, x2, x3, x4. Then they are 0. So then we conclude all coefficients should be 0. Next idea is, for example, suppose we have 2 polynomials, degree of p of x equal degree of q of x equals not necessarily equal. For example, suppose degree of p of x equals m, degree of q of x equals n, and they are equal. For example, suppose without loss of generality, suppose m is greater than or equal n. Suppose p of x1 is equal to q of x1 for more than m. For example, p of xn plus 1 equals q of xn plus 1. Then, and for suppose xi's are distinct numbers, distinct values, then we can conclude p of x equal q of x completely for all x. All coefficients are equal and m equals n degrees are equal. You can prove it by using idea 3. Okay, so let's consider homework 2. Prove this one. These ideas related to polynomials are useful in AMC, aiming, use sum, or IMO. Okay, so you can use them. Famous. They are so much basic. Idea 3 and idea 4 that you can use them. Okay, let's work on next problem. And if you want to learn all ideas like this in combinatorics, algebra, number theory, geometry, feel free to send a message to my WhatsApp number in the description. Okay, next problem, problem 17 of AMC 12A 2022. It is related to trigonometry. I want to tell you many important ideas in trigonometry to solve this problem. And also in AMC 10, we have problems related to trigonometry. So all the idea we want to say also useful in AMC 10 and also 12. Okay, so try this problem first on your own, then I will tell you important ideas in trigonometry, many important ideas, and then we'll try to solve this problem. Okay, so try first on your own. Okay, let me tell you some important ideas in trigonometry. Idea one. So the most basic one, here because I've told you four ideas. Idea five. So it's so much basic and it's an application of Pythagorean theorem, sine squared x plus cos squared x is 1. Idea 6 is that you say, okay, sine x plus y is what? Or sine a plus b is what? Is sine a cosine b plus cosine a sine b. You should memorize this. Idea 7. And then an application of this is sine 2a. It will be sine a cosine a plus cosine a sine a. It will be 2 sine a cos a. Next idea is cosine a plus b. Is cosine a cosine b minus sine a sine b. And also drawing unit circle can be so much useful. Drawing unit circle or trigonometric circle. It's what? Here you can consider this is for sine, and also let me tell you two more axes. This one is for cosine, this one is for sine, this one is related to tangent, this one related to cotangent. So for example, when we draw this one, this part is sine of that, this part is cosine of that, this is tangent of that, cotangent of that. Now we want to, so here we need to, for example, know sine alpha, negative alpha in terms of alpha. Okay, if we calculate sine alpha, sine negative alpha. Okay, so for example, it is alpha, it is negative alpha. So as you can see, their sines are negative of each other, and their cosine are equal to each other. So it will be what? It will be, and tangent are negative of each other, and cotangent. These two axes are so much helpful for this. You can imagine, after drawing, you can imagine this. So cotangents are negative of each other, tangent negative of each other. Or you can also use the formula. The tangent is sine over cosine. When sine is negative, cosine positive, then tan and cotangent will be negative. Okay, so here, sine negative alpha, idea 9, considering negative alpha, is negative sine alpha. Cosine negative alpha is cosine alpha. tan negative alpha is negative tan alpha. Cotangent negative alpha equals to negative cot alpha. Now let's consider when we have alpha and 180 minus alpha, okay? Or pi minus alpha. Then as you can see, their signs are equal, their cosines are negative of each other. And if you pay attention to tan, this one, tan is negative of each other, cotangent, again negative of each other. So if you write these things that I've told you, idea 10, let's write idea 10 here. For pi minus alpha or 180 degree minus alpha, we can say sine pi minus alpha equals sine alpha, cosine pi minus alpha, especially when you want to use cosine law in, for example, geometry problem. It is so much useful. It's negative cosine alpha, tan pi minus alpha is negative tan alpha, and cotangent pi minus alpha is negative cotangent alpha. Okay. Now let's consider pi plus alpha. So when it is alpha, it is pi plus alpha or 180 plus alpha. So as you can see, their sign will be what? Their sign negative of each other. Their cosine also negative of each other. So we can conclude, because tan is sine over cosine, tan will be equal to each other. And if you extend this, tan of both of them will be here and cotangent of both of them will be here. So we will conclude that tan and cotangent won't change. So let's try this idea, idea 11. For pi plus alpha or 180 plus degree plus alpha. Sine pi plus alpha is negative sine alpha. Cosine pi plus alpha is negative cosine alpha. Tan pi plus alpha is tan alpha. We can say cotangent pi plus alpha is cotangent alpha. Okay, it was idea 11. I told you alpha, this one, negative alpha. Okay, the important things are similar to this. For example, sometimes we have, let me tell you, for example, you want to see sine pi plus alpha is what? Okay. I told you pi plus alpha. For example, pi over 2 also useful. Pi over 2 is what? For example, this one is alpha, pi over 2 minus alpha. This one. So if you use congruent triangles, sine of this equal to cosine of this, cosine of this equal to sine of this. Okay, and so let's write also that part. Idea 12. Okay, idea 12 is what? Is sine pi over 2. This angle is what? Pi over 2 minus alpha, 90 minus alpha, 90 degree minus alpha. Sine pi over 2 minus alpha equals to cosine alpha. Cosine pi over 2 minus alpha equals to sine alpha. You can also use what? You can also use a triangle. We know sine is opposite over hypotenuse. Okay, so for example, if it's alpha, it is pi over 2 minus alpha. So sine pi over 2 minus alpha is what? Because it is sine, it is, for example, it is x, y, z. It is opposite over hypotenuse. So this is x is opposite to pi over 2 minus alpha, is adjacent to alpha, so it's cos alpha. Okay, so cosine is this. Tan pi square pi over 2 minus alpha is what? Sine this over cos, which will be cos over sine, will be cotangent alpha. And cotangent pi over 2 minus alpha is tangent alpha. Okay. Now, for example, let me tell you this. Suppose you want to find, for example, sine 270 plus alpha. We say, okay, first, it is sine 90 plus 180 plus alpha. Or let's write this, 180 plus, and let me tell you this. Alpha and 90 minus alpha, for example, it is here. This one was pi over 2 plus alpha, okay? 90 minus alpha will be something like this, okay? As an idea 13, suppose pi over 2 plus alpha, which is 90 plus alpha. And as homework, try to find all relationships. Let me see how many homeworks do we have. 2 homeworks, okay. So homework 3. Try to find all relationships here. Okay. So you say this one is 180 plus 90 plus alpha. We say sine 180 plus something is negative sine that part, 90 plus alpha. And sine 90 plus alpha, let me tell you this part. You can use the previous things. You say, okay, negative sine. Here we can say it is 180 minus 90 minus alpha. Okay? Do you agree it will be this? So we said minus sine of 180 minus something is sine of that part. Sine of 90 minus alpha. So sine of 90 minus alpha, we know is equal to sine alpha. Okay, so sometimes we can use these rules more than once to find the thing we want. Okay, so it was this, idea 11, idea 12, idea 13. Idea 14 is to draw the diagram. If you want to draw the diagram for sine 0, if you want to find sine 0, you can imagine this. Sine 0 is what? This one is 0. Okay? And look, sine, when you increase it in pi over 2, it will be 1, then it will be decreased to 0 in pi, and then to negative 1, and negative 1 to 0. Okay? And the period is 2 pi. So it starts like this one, like this one, like this one, and so on. It is 0, it is pi, this one is pi over 2, this one is 2 pi, this one is 3 pi over 2, and this part is 1, and this part is negative 1. Okay? It is the diagram of sine. So, diagram of cosine is what? In 0, it is 1. If you can again imagine unit circle, it is 1, and it will be something like this. So it is 1, it is negative 1, it is pi over 2, this one is pi, this one is 3 pi over 2, and this one is 2 pi. Okay, the period again is 2 pi. Now idea 16. Tangent. Again, you can consider unit circle. You will see, okay, for tangent, when it is 0, it is 0. It will be increased. When pi over 2, it will be infinity, okay? Asymptote. And also for negative, it will be like this. So for tangent, if we draw, we can see 0, it is 0. And it will be something like this. And they are what? It goes, approaches infinity. It is 0, it is pi over 2, negative pi over 2. Okay, and then it will be repeated again. Exactly like this one. You say, okay, this, continue like this one. And then it will be like this part. And then it will be like this part. And then it will be pi, it will be negative pi, and so on. Okay, the period is pi. Idea 16, idea 17, cotangent. Cotangent, as you can see, for 0 it will be infinity, positive infinity, then it will be in pi over to 0, negative, negative, negative infinity, okay? Because cotangent is this axis. Cotangent, if we want to draw, cotangent 0 is positive infinity, so when you increase it, it will be decreased like this, okay? So something like that. In pi over 2 it is 0, and then in pi it will be negative infinity. Okay, and it is asymptote, this part. And it will be repeated. The period is pi. Again, we have same thing, like this. Okay? These are asymptotes. Okay, they are cotangent, tangent. Again, some problems of AMC, we need these graphs. Okay, so idea 12, 13, 14, 15, 16, 17. And now let's use here, I told you, sine A plus B, cosine A plus B, and here, cosine 2A will be what? You can write it as cosine squared A minus sine squared A. Or if you use idea 5, you can say 2 cosine squared A minus 1, or 1 minus 2 sine squared A. Okay? Now for this problem, as you can see, we need sine 3x. So let me tell you, sine 3x is what? Idea 18. Okay, first, by the thing I told you, you can find sine 3x. Try this part first on your own to find in terms of sine x and cosine x. Okay? Try. Okay, so let's try this part together. Sine 3x is sine x plus 2x is then sine x cosine 2x plus cosine x sine 2x. Okay, so then we can say it is sine x times cosine x. We can write it as 2 cosine squared x minus 1. I told you in previous ideas, plus cosine x. Also, I told you this one is 2 sine x cosine x. So it will be what? Sine x, if you factor from sine x, it will be 2 cosine squared x minus 1 plus 2 cosine squared x, which will be what? Sine x times 4 cosine squared x minus 1, which is useful in our AMC problem. Idea 19. Try to find cosine 3x in terms of cosine x and sine x. Okay? Try this one. Okay, so let's try also this part together. Here it will be cosine x plus 2x. It will be cosine x cosine 2x minus sine x sine 2x by using the formula of cosine a plus b. Then it will be cosine x cosine squared 2 cosine squared x minus 1 minus sine x here 2 sine x cosine x, which will be 2 sine x squared cosine x. Then we can do what? We can factor from cosine x. It will be 2 cosine squared x minus 1 minus 2 sine squared x. So it will be what? It will be cosine x 2 cosine squared x minus 1 minus 2 times 1 minus cosine squared x. Okay? Now, if we simplify, it will be what? Cosine x, 4 cosine squared x, minus 2 minus 1 minus 3. Okay? So maybe for example, in some other problems, we need to know cosine 3x. We've calculated that. Idea 20. Idea 20 is what? When you want to, for example, change sum to product or product to sum. Okay. This one, for example, if you want to change product to sum, sine A cosine B equals 1/2. Again, in some AMC problems, it is useful. Sine A plus B plus sine A minus B. Idea 21. If we want to use cosine A cosine B, then it will be 1/2 cosine A plus B plus cosine A minus B. And if you want to prove them, you can prove them easily by using the formula sine A plus B. Here you look sine A cosine B plus cosine A sine B. Then here sine A cosine negative B, which is cosine B, plus cosine A sine negative B, which is negative sine B. And then two parts will be cancelled and we will reach this. So I told you 3 homeworks, I think. So homework 4, try to prove this by the previous ideas. Prove. Homework 5, try to prove also this one by same thing. Now, we found product of sine cosine. We found product of cosine cosine. So what is left? Idea 22. Sine A sine B. For this one, we say 1/2 cosine A minus B minus cosine A plus B. Okay? So it is the way that we change product to plus, addition, or subtraction. Okay, idea 23. If we want to change addition to product, for example, cosine A plus cosine B, you can use again this part, idea 21, to prove this. It is 2 times cosine A plus B over 2 cosine A minus B over 2. You should memorize these things before exam. Minus B over 2. Homework 6, prove this one. Homework 7, prove this one. Idea 24. If we want to calculate cosine A minus cosine B, one way is to say, okay, cosine negative cosine B is cosine 180 minus B. Or if you simplify that, it will be 2 sine A plus B over 2 sine B minus A over 2. Okay? And the next one, idea 25, is sine A plus sine B, which is 2 sine A plus B over 2 cosine A minus B over 2. Again, you can use previous ideas to prove these things. Homework 8. Homework 9. Okay, and for example, if you have sine A plus cosine B, you can write cosine B as, for example, sine 90 minus B and simplify this. Okay. I told you 25 things. Okay, let's try now this problem 17 from AMC 12A. And the ideas, as I said, are useful also in 10A. So here I told you, let's try to simplify. We say A sine x plus 2 sine x cosine x. And I told you sine 3x is what? We've calculated that. Sine 3x is sine x 4 cosine squared x minus 1. So it is sine x times 4 cosine squared x minus 1. Now here, we know sine x is not 0 because x is from 0 to pi. If you consider unit circle here, let me show you. When it is from here, open 0 to open pi, sine x is always positive. Okay, so it cannot be 0. So that's the reason that we can divide both sides by sine x. Okay. Now it will be a1 plus 2 cos x equals to 4 cos squared x minus 1. Here we want to factorize this. And we use a squared minus b squared. Let me tell you general formulas for factorizing. Idea 25, idea 26. We know a squared minus b squared is a minus b times a plus. But we don't have factorization for a squared plus b squared. But for 3, we have for both of them. A cubed minus b cubed is what? And then I will tell you general form for an minus bn and an plus bn. It's a minus b, a squared plus ab plus b squared. Okay? And idea 28, a cubed plus b cubed is a plus b times a squared minus ab plus b squared. Okay? Idea 29 is a to the 9, a to the n minus b to the n for integers, positive integers. A minus b times an minus 1. Try to find the second term first on your own. So this one is a minus 1 plus a minus 2b plus a minus 3b squared 2bn minus 1. Okay. Idea 30. So it is for when n is a positive integer. Idea 30 for an plus bn, as you can see, if you want to factorize a plus b, it is only correct for 3, not 2. So it's for n positive integer and n is odd. Okay. N is odd. Then here it will be an minus 1 plus an minus 2b. Sorry, here it will be minus. Minus plus alternatively. Plus an minus 3b squared. And last one will be plus bn minus 1. Next identity, and these identities were also useful in AMC 2022. Okay. Idea 31. If we consider an minus bn, and I want to say it is multiple of 8 plus b, but it is correct when n is positive integer and n is even. Like a squared minus b squared. It's a plus b times a minus b. And here it will be an minus 1 minus an minus 2b plus an minus 3b squared. 2 minus bn minus 1. Okay? It's idea 31. Now, okay. Let me tell you also some important identities, basic identities, telescoping rule, something like this. So the first important idea that all of you, I think, know this is n times n plus 1 over 2. If we have 31, if we have, for example, an arithmetic sequence, a1 to an, you say n times a1 plus an over 2. If you want to know number of elements, for example, it is a plus d. For example, like what? You say, okay, 6 plus 3, or let's write this, 5 plus 3, 8 plus 3, 11. And mod 3, they are 2, so 101. If you want to know number of them, last one minus first one over a common difference, which is 3 plus 1. Okay, so it will be 101 minus 596 over 3 plus 1, which is 32 plus 1, 33. Idea 33. If you have 1 squared plus 2 squared to n squared, it is what? N times n plus 1 times 2n plus 1 over 6. Idea 34 is when we have 1 cubed. Some of them useful also in USAML, in AME. N cubed is what? Is n times n plus 1 over 2. Maybe in some years in AMC we have that. Idea 35, identity, is hockeystick identity. And so much helpful and powerful. It is what? It is R choose R plus 1 choose R. And there are lots of problems that you can solve, for example, with Huggins identity, with Vandermon's identity. If you want to know those problems, feel free to send message to my WhatsApp number in the description. Okay, to n choose R equals m plus 1 choose R plus. Idea 36. This identity useful Vandermon's identity in AMC problems also. AME problems. It is what? Let me tell you the idea, because if you remember the idea, then solving the remembering this will be so much easier. Suppose, for example, we have m girls and boys, and you want to select k of them. Okay. So one way you say, okay, so it will be m plus n choose k. And then we can use case word. You say, okay, m choose k, k girls, 0 boy, k minus 1 girls, 1 boy, and for example, k minus 2 girls, 2 boys, and so on. 2 m choose 0, n choose k. Okay. Now, an important application of this that also was useful in AME is this one: n choose 0 squared plus n choose 1 squared plus 2n choose n squared equals 2n choose n. You can prove it by Vandermon's identity. How many homeworks did we have? Homework 9, homework 10. Prove this one by using Vandermon's identity. Okay. I told you 1 cube n cube. Now let me tell you 38. 1 plus r squared to r to the n. Geometric sequence, some of them. It's Rn plus 1 minus 1, R minus 1. Or you can negate both numerator and denominator. Most of the time when R is greater than 1, we write like this, and R less than 1, we write like this. And I39, sometimes absolute value of R is less than 1, and then we want to calculate 1 plus R squared, and so on. So in this part, R to the n plus 1, because it will be infinity, it will be 0, it will be 1 over 1 minus R. Also, you can prove it with other ways. Let me tell you the idea for solving this. Find inside itself. We have problems in AMC and also SMT for Stanford. Inside itself. It means what? It means that, for example, you want to calculate 1 plus 1 half. Or let me tell you something else. For this one, useful, for also other things useful, powerful thing. It is what? For example, you say, okay, this is S. You multiply this by s, you find inside itself and try to cancel out many terms. 2s is what? 2s is 2 plus 1 half plus 1/4 and so on. Then when you subtract, 2s minus s is s. Then this part will be cancelled with this part, okay? So it will be 2. So s equals 2. Or, for example, you say 1 plus 1 plus 1 plus 1, 1 plus 1. You can do the same thing, okay? As homework what? Homework 11. As homework 12, we can solve this one. Square root of 2 times square root of 3 times square root of 2 times square root of 3 and so on. Try to find these two terms. Okay, I told you inside itself. And one part is left. Telescoping rule. That also was useful in AMC 10, 2022 and also in AMC 12, 2018. Homework 13. AMC 10, 2022, we had a problem that could be solved with this telescoping rule. AMC, I remember these two problems. AMC 12, 2017 or 18. If you want to know exact problems or what, as I said, send message my WhatsApp number. The telescoping rule is what? So, suppose 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4. Also, one problem in Berkeley Math Tournament, BMT 2022, can be solved with this one. 1 over 100 times 101, okay? Try to calculate this one first on your own. And let me tell you also another one. 1 times 1 factorial plus 2 times 2 factorial plus 3 times 3 factorial to 100 times 100 factorial. Try to simplify these two terms by using telescoping rule first on your own. Okay, for first one, you can say 1 over 1 times 2 is what? Is 1 over 1 minus 1 over 2. 1 over 2 times 3 is what? Is 1 over 2 minus 1 over 3. 1 over 3 times 4 is what? Is 1 over 3 minus 1 over 4. To 1 over 100 times 101 is what? Is 1 over 100 minus 1 over 101. And then it will be cancelled like this, so the sum will be 1 minus 1 over 101, which is 100 over 101. So this one we've calculated. The approach is important. You don't need to memorize it. And for this one, you can solve it exactly by same rule, the telescoping rule. And you can prove, okay, so let me tell you. Next one is 1 times 1 factorial is 2 factorial minus 1 factorial. 2 times 2 factorial is 3 factorial minus 2 factorial. To 100 times 100 factorial, which is 101 factorial minus 100 factorial, okay? So the sum will be 101 factorial minus 1, okay? So we've calculated these two things by telescoping rule, okay? 41 ideas. Now, here, we know it is a squared minus b squared. I told you how to factorize. It's 2 cosine x minus 1, 2 cosine x plus 1. Now, when we divide both sides by 1 plus 2 cos x, we should pay attention. It is not 0, okay? It is so much useful and basic, and it causes careless mistake if you don't pay attention. 41, when AB equals AC, when you want to divide by A shouldn't be 0. So you can say two cases. A is 0, then both of them will be 0. If A is not 0, then we can divide by A, B equals C. Now here it will be idea 41, 42. Okay, so let's, here we can consider two things. If 1 plus 2 cos x 0, then cos x equals negative 1 over 2. In trigonometry, 4 ideas are left. I will tell you after solving this problem. When cosine x equals to negative 1 over 2, because x is from 0 to pi, you can easily say, okay, x, we know cosine 30, cosine 60 is 1 half. So cosine 120 or 2 pi over 3. The next one, so in all cases, for all a's, we have one answer. X equals 2 pi over 3, both sides will be 0. Then we want to consider second part. Now suppose 1 plus 2 cos x is not 0. Then we divide both sides, so a equals 2 cos x minus 1. So if x is not 2 pi over 3 and it is equal to 2 cos x minus 1, then it will be okay. Now we can draw the diagram. Okay, so drawing the diagram is so much useful, and I can say it as idea 42. Okay, 43. Idea 43, draw the diagram. In many problems of AMC AME, drawing the diagram can be so much helpful. So here without drawing diagram also we can understand, but if you draw, for example, for especially first problems, then after solving some problems you can imagine. Okay, so if we want to draw this, we want to draw from 0 to pi, and we know cos is from 1 to negative 1. So it's a start 2 times 1 minus 1, 1. Then 2 times negative 1 for pi. Minus 1, negative 3. Okay, so it will be something like this. Now we know if x equals 2 pi over 3 cosine x negative 1 over 2. So 2 times negative 1 over 2 is negative 1 minus 1 minus 2. Okay, so minus 2, for example, if you consider this part is x equals 2 pi over 3. Okay, we want at least two answers. If x equals 2 pi over 3, if a equals negative 2. Again, for this part also we reach if a equals negative 2. Again, x equals 2 pi over 3. We reach one answer, but it says we need at least two answers. Okay, it has more than one solution. So except a negative 2 from 1 to negative, from negative 3 to 1, all of them are good. Okay, because we have one answer. X 2 pi over 3 for case 1 and another x for our answer. For example, this x. Okay, so P will be what? Negative 3. Q will be what? Negative 2. Negative 2 to 1. Okay, now we can say P plus Q plus R is what? Negative 3 minus 2 minus 5 plus 1 minus 4. So the answer is choice A. Now here, for example, look, it was cosine negative 1 over 2. It was easy because x was from 0 to pi. Sometimes we have, for example, x from 0 to 30 pi. Then we want to find all answers. So idea 44 is, for example, when sine x equals to sine alpha, the general forms are what? X equals to alpha plus 2 pi k, or pi minus alpha plus 2 pi k, which k is integer. Idea 45. If sine cosine x equals to cosine alpha, Then x equals to alpha plus 2 pi k and negative alpha plus, or you can write it as, let's write it like this, plus minus alpha plus 2 pi k, which k is an integer. Okay. Idea 46. Tangent x equals tangent alpha. So here we can say x equals alpha plus pi k, which k is integer. And idea 47, we can say cotangent x equals cotangent alpha. Then x equals alpha plus pi k, which k again is an integer. Okay, idea 48 in easy problems of AMC. Useful when you have square root of n, you can say, for example, you can say 1, a to the 1 over n, and on. When you have, for example, square root or something like this, nth root, you have two approaches for solving the problem. If it is not related to this, raised to the power of n. Second one is to consider it as a variable, for example, t. Changing variable. Also, changing variable can be so much useful. It will be idea 49. Okay, as homework 16, because homework 16, because I told you these things, let me tell you which identities. These identities. Homework 16, you can. Okay, now this problem is related to logarithm AMC 12A 2022. Also, in many other years, we have logarithm. I've told you 49 ideas. Now, before that, let's finish homework 16. Let me tell you homework 16. For this one, okay, you can solve by using these identities. AMC 10B problem 17, 2022. You can solve it with modulo. Also, you can solve it with only using these identities. Okay. If you want to know how to apply, as I said before, send message to my WhatsApp number. Okay. Okay, so try to solve this problem related to logarithm first on your own. Then I will tell you important ideas in logarithm, and then you can try again if you couldn't solve. Try first on your own. Okay, so let me tell you idea 50. Idea 50 is when we have logarithm, the definition is what? When we say logarithm of log a to the base b equals m, it is equivalent that b to the m is a. Okay, this definition in many problems useful. Idea 51, when we have log a to the base b, a should be positive and b should be greater than 0 and also b shouldn't be 1. And idea 52, the graph of logarithm is what? If you want to draw we have this part, it is log x to the base b. And this one is x, this one is 1, this one is for a case that b is greater than 1. And if b is from 0 to 1, we said b has to be positive. It will be something like this. Vertical asymptote here, and it will be like this. B greater than 0, less than 1, okay? Okay, idea 52 was this. Idea 53. If we have a log a to the base b plus log c to the base b, then we can say it is equal to log ac to the base b. Idea 54. If we say log a to the base b minus log c to the base b is equal to log a over c to the base b. Idea 55. If we have log a to the m to the base b to the n, it will be m over n log a to the base b. Idea 56. If we have log a to the base b times log b to the base c, we can cancel these two b's and it will be log a to the base c. For example, it is useful when what? Idea 57, when you see ln of, for example, a, it's a log a to the base e. Euler's number. Idea 58, sometimes we want to find, for example, log a to the base b. So you can say it's log a over log b, and the bases are equal. For example, you can say n is c. Okay, this application of these. So we worked on the graph, on all these things. Okay. Now, here, if we want to use, it says bases of all of them equals 10. So this part is what? It's log 2 squared times 5. If you use AB and then use something to the power of something, you say, okay, it's equal to log 2 squared plus log 5. Now, let me tell you something. We know log 10 to the base 10 is 1 because of the definition, because 10 to the 1 is 10. So we know that 10 is what? 2 times 5. So log 2 times 5 to the base 10 is 1. It is equal to what? Log 2. Let's ignore writing 10. Log 5, it is equal to 1. So if we consider, for example, log 5 equals x, then log 2 equals 1 minus x, okay? So this one, it's what? If we use the power here from idea 55, we can write it as 2 log 2 plus log 5, okay? So 2 log 2 is what? Is 2 times 1 minus x. Log 5 is x, so it will be 2 minus x minus 2x plus x. So the first one is x cubed, the next one is 2 minus x cubed plus log 8 is what? 2 cubed, 3 log 2, which is 3 times 1 minus x. Okay. Log 0.25 is log 1 over 4. Log 1 over 4 is 2 to the negative 2. It's negative 2 log 2. So it's negative 2 times again 1 minus x. Okay. So we can do something because we have many. Okay, no problem. We could consider log 2 as x and then this one. Then we had only one thing related to 1 minus x. Okay, if you calculate, it will be x cubed plus 2 minus x cubed. 3 times negative 2, negative 6 times 1 minus x squared. Okay? Okay, if we simplify this one here, we need to use binomial theorem. Okay, let me tell you binomial theorem is what? Idea 59 is a plus b to the power of n. You say n choose 0, a to the n. Because we select only, we select 0, b, n, a. Or you can say n choose n, a, n. Both of them equal. N choose 1, we select 1b, it will be a n minus 1b. Plus n choose 2, a n minus 2b squared. 2 n choose n, b to the n. Okay, so if we use this identity, this binomial theorem, it will be x cubed plus x cubed minus 3 times 4. It will be what? 3 times 2, 6 x squared plus 12x minus 8. Here it will be negative 6x squared plus 12x minus 6. So 6x squared, 6x squared. And here will be what? Here, sorry, it's 2 minus x cubed. We should negate the signs. It will be minus x cubed plus 6x squared minus 12x plus 8. Okay, then it will be 6x squared. Negative 6x squared, negative 12x. Negative 12x, and also x cubed, negative x cubed, and 8 minus 6 is what? Is 2. So the answer is choice C. Okay, as homework 17, you can try this problem, this logarithm problem, only with the rules I've told you. Okay, so I told you 59 ideas. Okay, now let me tell you some ideas in I-59, idea 60, and related to quadratic formula. If we have ax squared plus bx plus c equals 0, or let's consider this one p of x, then we know it opens up if a is positive, it opens down when a is negative, and idea 61, the roots are x equals negative 1 plus minus root b squared minus 4ac all over 2a. And here we consider delta or discriminant b squared minus 4ac. Idea 62. Here, if delta, we want to see number of roots. If delta is negative or discriminant negative, we don't have any real roots. If delta or discriminant is 0, then we have one root like this, one repeated roots. If delta is greater than 0, then we have two roots. If a is positive, it opens up, a negative opens down. We have two distinct roots. Another thing, I-63 is a special case of Vieta's formula. If you have roots, R1 plus R2 is negative B over A, R1, R2 is C over A. Now, vertex of the parabola is what? Idea 64. So if you consider, for example, this graph, this one is what? If you want to consider the coordinate of this part, suppose for example it is v, x, v, you can calculate it by changing to perfect square, and you can see that it will be negative v over 2a. And y is what? Y of v, you can replace xv in our quadratic equation and find that it is this. Now let's try problem related to quadratic formulas and equations, and it is so much helpful. Okay, this problem, we had this problem in AMC 12A Fall 2021. Also, we had this problem in 10A. Okay, so try this problem first on your own. Okay, let's try this problem together. It says a quadratic polynomials with real coefficients and leading coefficient 1 is called disrespectful if the equation p of x is equal to 0 is satisfied by exactly 3 real numbers. Among all the disrespectful quadratic polynomials, there is a unique such polynomial p of x, for example p hat, for which the sum of the roots is maximized. What is p hat of 1? Okay, so let's consider p of x. It says leading coefficient is 1, so it will be this. And then it says p of x equal to 0 has exactly 3 real roots. So here, if our roots are r1, r2, so if it is 0, we know p of r1 and r2 is 0. So we conclude p of x is what? Because p of something is 0. We know the roots are r1, r2. We know only p of r1, r2 is 0. So p of x equals r1 or p of x equal to r2. Now, for example, here, suppose we have two roots, x1, x2. And here, if you have x3, x4, if two roots be equal, then r1 equals r2, then we cannot have three roots. Okay? Pay attention. For example, if x2 equals to x3, because we have three roots, one case is that x2 equals x3, and for example, two difference. Then we have three roots. If x2 equals x3, then p of x2 equals p of x3, r1 equals r2, then we have at most two roots for this one, contradiction. So the only case is that one of them should have one root, one of them has two roots. Okay, so for example, we can call x1, and here x2, x3. And so without loss of duality, suppose first one has one. So when it has one root, I told you, it means that by the ideas I told you, the discriminant of this is 0. So x squared plus bx plus c equals r1. So it will be x squared plus bx plus c minus r1. The discriminant here is what? B squared minus 4 times c minus r1. We know this one is 0. Okay? And now, because r1, r2 are roots here, so by Vieta's formula, or the idea is, I told you r1 plus r2 is negative b. Here, I've told you negative b over a, r1, r2, c over a. So r1, r2 is what? Is c. c over 1. And we know this part is also 0. Okay? And this one, because we have two different roots, d here is 0, d here is positive. Okay, so x squared plus bx plus c equals r2. Then x squared plus bx plus c minus r2 is 0. Discriminant here should be positive, means b squared minus 4 times c minus r2 should be positive. Okay, now here I want to find r1. For example, a relationship between r1 and r2. We know b is what? Negative r1 minus r2. Because we have b squared, you can write it as r1 plus r2 whole squared minus 4 times r1 r2 minus r1 equal to 0. Okay? So, if we expand this by binomial theorem, r1 squared plus r2 squared plus 2r1 r2 minus 4r1 r2 plus 4r1 equal to 0. So, we can conclude this part r1 plus r1 squared plus r2 squared, 2r1 r2 minus 4r1 r2 will be negative 2r1 r2, so we can write r1 minus r2 whole squared plus 4r1 equal to 0. So we can find r1. Let's write this. If we can write r1 minus r2 whole squared equals negative 4r1, and then we can take square root. R1 minus r2 is plus minus square root of this. You can take 4 outside, square root of this one. Okay, now, or you could use also quadratic formula for calculating r1 in terms of r2 and r1. Okay, so now we want to see, we should select plus or minus. If we check this one, again we can say r1 plus r2 whole squared minus 4 times r1 r2 minus r2 is positive. If we expand this, it will be again r1 squared plus r2 squared plus 2r1 r2 minus 4r1 r2 minus 2r1 r2 plus 4r2 is positive. So we can say r1 minus r2 whole squared plus 4r2 is positive. Okay, now pay attention to all things here we have. Let me minimize. Okay, and try to see here. We can select plus or minus. Okay, which of them? Try first on your own. Okay, let me tell you how you can prove. Look, do you agree we know R1 minus R2 is negative 4R1? So here we can replace it and it will be negative 4R1 plus 4R2, which is positive. So if you divide by 4, it will be R2 minus R1 should be positive. So R1 minus R2 should be negative. So we conclude what? We conclude that R1 minus R2, because it is negative, it's negative 2 times root negative R1. Also, we know R1 is negative, okay? R1 cannot be 0, because if R1 equals 0, then R1 equals R2, then we don't have 3 roots for P of X, okay? Because then here we should have 1 root and 2 different roots. So R1 negative and this. So we can find R2 in terms of R1. R2, if we take it here and switch left hand side, right hand side, R1 plus 2 times root negative R1. Okay. Now we found R2 in terms of R1 and on. The problem says what? The problem says sum of the roots is maximized. So sum of the roots is what? R1 plus R2. It's what? R1 plus, if we replace R2 with this, R1 plus 2 times negative R1. So it is 2 times R1 plus root negative R1. Okay. Now we want to maximize this part. Okay, so here 2 R1 minus R2 minus plus. Okay. Now we want to find maximum of this part. Try to find maximum of this part first on your own for R1 negative and real numbers. So let me tell you, for solving this, I want to tell you new methods. I told you 63. I want to tell you two, three different ways to find maximum. You know, R1 is negative. Okay, we said R1 is negative. Here we set R1 negative because it's inside square root. So we can say R1 equals negative t squared, which t is positive without loss of generality because it has no effect on t squared. So it will be what? 2 times negative t squared plus square root of t squared, which will be what? 2 times negative t squared plus t. Now, solution 1 for this one. I want to use an identity that write it as sum of the squares, I64. Okay? Sum of the squares, use square things or parabola. And calculate this, try first on your own. Okay, how can I write sum of squares? I say, okay, negative t squared plus t, I can write it as negative t squared minus t. Okay, so I can write as negative t minus half squared, then we have t squared minus t plus 1 over 4, then we subtract minus 1 over 4. So it will be negative t minus half squared plus 1 over 4. Okay, so we know this part is less than or equal to 0, so this one is at most 1 over 4, and equality happens when t equals 1 half. Okay, so this one will be 1 over 4, 2 times 1 over 4 will be 1 over 2, the maximum. But for which t? T equals 1 half, so R1 is what? R1 is negative 1 over 4. Okay, now, second solution. Idea 65. When we have parabola, when you want to find, for finding maximum, you use vertex of the graph. Because we have this is a parabola, it opens down, and we should find this vertex, and the roots are what? 0 and 1. So in 1 half, we will reach the vertex. If we can't find the roots, the midpoint. So again, t equals what? T equals 1 half, then R1 equals negative t squared, which is negative 1 over 4. Idea 66. We can use derivatives, if you know derivatives. We can say, okay, we have negative t squared plus t. If we take derivative, it will be negative 2t plus 1. We consider it is equal to 0. Again, t equals 1 half, and R1 equals negative 1 over 4. Okay. Also, we can use other things, but I've told you 3 ways to find maximum. Some of the squares also useful when you want to say something 0. For example, when you say 2 squared equal to 0 and they are real numbers, then you can say that they are 0. Okay, this idea also useful in AMC. So here we found R1 is what? Okay, now that we found R1 is negative 1 over 4, now we can find R2. Why? Because R2 is R1, which is negative 1 over 4, plus 2 times square root of negative of this 1 over 4. So it will be what? Negative 1 over 4 plus 2 over 2, which is what? Which is 1, which is 3 over 4. Now the problem says what? Find P of 1. Okay, so the roots are negative 1 over 4, 3 over 4. Negative 1 over 4, 3 over 4. We know sum of the roots is negative b, so b is negative sum of the roots. 3 over 4 minus 1 over 4, 2 over 4, 1 over 2, so b is negative half. C is product of the roots, which is negative 3 over 16. Now it says p hat of 1 is what? So you say x squared, which is 1 plus b. It's a 1 plus b plus c. b is what? Minus 1 half minus 3 over 16, which is what? If we use 16, it will be 16 minus 8 minus 3. It's 5 over 16. Okay, so the answer is choice A. Okay, now I want to tell you another thing related to floor of something. We have an idea here for these types of problem, idea 67. Let me tell you the idea is what? For idea 67, when you see floor, and it is useful also in AME. Let me see how many homeworks do we have. Homework 17? Okay. Homework 18. We have a problem related to Amy. It is so much harder than this, but we use same idea. Also, we have problem in PMO, Philippine Mathematical Olympiad, and also in other AMC problems. So that can be solved with this. When you see floor of something, you are working with floor or, for example, fractional part. You can say x equals k plus r, which k is integer part, and r is fractional part. And the important thing is that r from at least 0 greater than equals 0 less than 1. And by using this inequality, you can solve the problem. Okay. So for this one and many other problems, you can use this idea. Try this problem first on your own. Okay, so let's try this part. Here we know n, if we cross multiply n plus 1000 equals 70 root n, floor of root n. And here we know n is integer, okay, because right hand side is integer, because it's floor of something times 70. So left hand side is integer, so n is integer. Now, by this point. And also the problem says how many positive integers, okay? The other thing, we know n is integer, so it doesn't have any fractional part, but root n. Here we have floor. So we can say root n equals k plus r. And then n equals what? K plus r whole squared. Okay? And then we can say what? We can say n is what? N is k plus r whole squared plus 1000 equals what? 70 times floor of this, which is 70k. Now, k squared plus 2kr plus r squared plus 1000 equals 70k. And then, because we know r is from 0 to 1, we can write it as what? as a quadratic equation in terms of r. So it will be r squared plus 2kr plus k squared plus 1000 minus 70k. Okay, or we can say k squared minus 70k plus 1000 equal to 0. So r will be what? R in terms of k. It will be negative 2k plus minus square root of 4k squared b squared minus by using quadratic formula I told you. Minus 4 times this minus 4k squared plus 280k minus 4000. Okay? All over 2. So we can simplify. We can divide both numerator and denominator by 2 plus minus inside square root. You should divide by 4. So it will be 70k minus 1000. Okay. So it is what? At first, because we know k is positive integer. Okay, because n is positive integer and square root of 1, the first one, is k is 1. So we know because n is positive integer, k is also positive integer because the square root of n is at least 1. And r we know is from 0 to 1, at least 0. So if you select minus, then minus k minus a number like this will be bad. Okay? And also we know inside square root should be what? Should be positive or greater than or equal to 0. 70k minus 1000 should be at least 0. And also this one from 0 to 1. So we should select plus here. If it is minus, it will be negative. So negative k plus square root of 70k minus 1000 should be from 0 to 1. Okay? Now try to analyze this and see for which case it is possible. Try the rest on your own. Okay, let's try to analyze this part. Here we take first we want to work on this part. K is less than or equal to square root of 70k minus 1000. So here we will see what we raise both sides to the power of 2k squared less than or equal to 70k minus 1000. Then it will be k squared minus 70k plus 1000 is less than or equal to 0. So try to analyze this part. Okay, so here we can factorize, or you can also use quadratic formula. K minus 20, K minus 50, okay? So less than or equal 0. So we know it opens up, so from 20 to 50 it is negative, and outside positive. So we can conclude K we should be in these parts, okay? So K is at most 50 and at least 20 from the first part, okay? And this is so much useful. We can define it as, let me tell you, idea 68. That, for example, if we have ax squared plus bx plus c, you want to see when it is positive, okay? So, for example, if you have two roots r1, r2, it is 0, 0, then it will be something like this, okay? And if a is positive, then we know it opens up. Here it will be negative, it will be positive. If a is negative, it will be something like this. So here positive, here negative, and here 0. Okay, and for example, if here it was for the case that discriminant is positive. If discriminant is 0, then we have this part. If a again is positive, then for root, we have one root, for example, r. In r it is 0, and in all other parts it's negative, positive. If a is negative, it is r, it is 0, it will be negative. If discriminant is negative, so we know it's always positive or negative, it depends on a. So then if a is positive for this case, it is always positive. If a is negative, it is always negative, okay? Now here we found case from 20 to 50. If you pay attention to the diagram, we will understand this what. Okay, now let's consider this part. If we consider this part, root 70k minus 1000 is less than 1 plus k. If we raise it to the power of 2, 70k minus 1000 is less than k squared plus 2k plus 1. So k squared minus 68k plus 1001 is greater than 0. Okay, so try to find all possible k's for this part first on your own. Okay, here this is a quadratic equation, quadratic term, polynomial. If we find the roots, then we know. Before that and after that, it is positive. Okay, so if we find the roots, we need to find the roots. K equals 68 minus b plus minus, I told you the quadratic formula, 68 squared minus 4 times 1001 over 2. So we can divide both numerator and denominator by 2, so it will be 34 plus minus square root of 34 squared minus 1001, okay? So if we calculate 34 squared, it will be 4 4 16, or we can say 34 squared is 4 times 17 squared, which is 289. Okay, 4 times 9, 36, we have 3. 4 times 8, 32, 3, 35. 3, 4 times 2, 18, plus 3, 11. So it will be 1156. Okay, now we should do what? If we calculate this, it will be 34 plus minus 1 minus 1001. It will be minus what? Minus 156, 155. Okay, so square root of 155 is what? Is 34 plus minus 12 point something. Okay, and let me tell you an approach. For example, if you want to find first decimal digits, okay, so the idea is, let me tell you, idea 68, idea 69. Square root of 155 is what? If you want to find one decimal digit, you add 2 zeros for each decimal digit. So you from right digits 2 by 2, then you say, okay, for 1, 1 times 1. Then you subtract. Then next 2 digits, you multiply always in each step this by 2. 20 what times what? You should place for the same number. So it's 44. 11 next 2 digits 0 0. Then you take these two here, 12. Again, we have 12 here. You multiply by 2. You should do this step again and again. So 240 what times what? You should place same digit. If you place 5, it will be 1200. It will be small. It will be greater than 1100. It should be smaller than this, but great as possible. If you place 4, then we will have what? 4 times this. So 4 times 4, 16. We have 1. 4 times 4, 16 plus 1, 17. We have 1. 4 times 2, 8 plus 1, 9. Okay, so it will be this, and because it is 2 zeros plus 4 decimal digit, is 12.4. In this problem, we don't need this, but in one problem of AMC 2022, you could use this one to find answer quickly. So it will be homework what? How many homeworks did we have? Homework 20, homework 21. I don't want to know exact problem was what. As I said before, send message to my WhatsApp number. Okay. Now, here I told you idea 69. Okay. So 34 plus 12, which is what? Which is 46 point something. And 34 minus 12 is 22, 21 point something. Okay. So because we know k is integer, k is at least this, k is greater than this, and k is less than this. So, and we want to also consider star, that k is from 20 to 50. So all k's that are possible, 20, 21 satisfy this, 47, 48, 49, and 50. Okay, for this case, we will find a unique OR that satisfies the things we want. 2, 4, 6. So the answer is 6. So the answer is choice C. Okay, so next one, next idea, 68, 69. I-70, you should know long division. And we have AMC problem. We have this idea in polynomials, but also you can solve this problem with long division easily. It will be homework. What? Homework 22. Okay. And next idea, idea 71, you should know partial fractions. And we have AMC problem, homework 23, that can be solved with partial fraction. You should know this is what. If you want to know partial fraction is what, send message to my WhatsApp number. And another one is that idea 72. When you want to find remainder, when do you divide ax divided by b of x? The approach is that you consider b of x equals 0. And for partial fraction, we have two approaches for finding that. There are so much useful in AMC problems, also useful. And ax, when you want to divide ax by bx, when you want to find remainder, the approach is to consider b of x equals 0. Again, AMC, let me tell you, homework 23, homework 24. In AMC 12A 2022, we had one problem. Homework 25, that you should use this approach. I released the solution of this, I think, in my previous videos. AMC 10A, 10B, and 12B. We had one problem in common in 2022 that you could solve this with idea 72. Okay, if you want to learn 40, 50 important ideas and formulas in each topic, the most repeated ideas. In combinatorics, algebra, number theory, and geometry, some important formulas in geometry. Feel free to send message to my WhatsApp number in the description and comments. Here we've considered 72 ideas in algebra. Also, we'll consider ideas in combinatorics, number theory, and geometry. Also, for AMC 1012, AMC 8, AME, USAMA, all these things. Okay, if you want to learn all of them, want to solve more problems, want to find background ideas, feel free to send message to my WhatsApp number in the description comments.